On our final part 4 of our deep dive on work orchestration for agentic engineering, we're going to get into a deep dive on OpenAI's new Symphony. This is a system for doing work-based system orchestration using a linear task board, for example. We'll explore shifting human control up to the work level, managing workspaces, policies, and ticket-based state, and explore architectural alignment and harness integration options.
Welcome. Today, we're exploring one of the most exciting shifts in modern agentic engineering, moving human control away from live coding sessions and up to the work level itself. As we walk through this overview, we'll trace the journey from session-level micromanagement to true work-level control, where your issue tracker becomes your new command center. We'll look at Symphony as a prime example of this shift and see exactly how the human role and verification processes are evolving rather than disappearing. Finally, we'll explore how this structurally transforms the entire experience of engineering as AI agents move far beyond the IDE, wrapping up with a simple comparison and your key takeaway. Get ready to spend less time in the weeds and more time guiding the big picture. Let's dive in. Let's explore a major shift in how we interact with AI, moving from session control to work control. In earlier forms of AI-assisted development, you really had to hold the AI's hand. You were tightly attached to your local session. Think about how that usually goes. You explain a task in the chat interface, correct the agent step by step, continually reload missing context, and watch the entire process closely so you can intervene when it goes off track. In this model, your coding environment or command line is your main control surface. Now, that approach can work perfectly fine for small, short-lived tasks, but it scales terribly. Why does it scale so poorly? Because relying on session-level control creates major bottlenecks. As a human supervisor, you can only watch so many live sessions at once. Context has to be repeatedly reintroduced, and every time something fails, you have to handle the retry manually. On top of that, the actual state of your project often gets trapped deep inside a long chat history. Ultimately, you end up spending way too much effort managing local execution instead of focusing on the overall workflow. But as AI orchestration improves, micromanaging every single step becomes unnecessary. This brings us to a much more efficient, higher-level alternative. In work-level control, your primary unit of interaction is no longer a live, continuous prompt stream. Instead, it is the work item itself. That work item might be a project ticket, a software issue, a defined task, a formal work request, or even a queued job in an automated workflow system. You define the unit of work, and the system coordinates the entire implementation process around it, freeing you from the chat box and letting you focus on the big picture. Let's explore what work-level control actually means. At its core, work-level control means that you, the human, are primarily responsible for shaping and supervising the entire lifecycle of a piece of work, rather than directly carrying out every single implementation step by hand. Instead, your focus shifts to the bigger picture. At this level, you spend your time defining tasks clearly, setting constraints and acceptance criteria, and deciding what takes priority. You are the one reviewing the results, handling any exceptions, and either approving the work or redirecting it. You also take on the role of refining the overall policies and the workflow itself. Meanwhile, the system takes care of the implementation details. It focuses on executing that bounded work. The system maintains the state of the task, preserves or restores your workspace continuity, and runs the necessary validations. If something fails, the system handles the retries. It also surfaces the intermediate status so you always know what is going on, and it prepares the final outputs for your review. This represents a massive change in the human-machine relationship. In this model, you are not reduced to simply being a prompt author. Instead, you step up to become an operator, a reviewer, a workflow designer, and a work manager. And that fundamental shift is exactly what this lesson is all about. Let's talk about why the issue tracker starts to matter so much in this new paradigm. Once control moves to the work level, the systems we use every day, like Linear, GitHub Issues, Jira, or really any task workflow system, take on a completely new level of importance compared to a purely human-coded workflow. They are no longer just passive databases where work is recorded after the fact. Instead, they become active control surfaces for orchestration. Why does this happen? Think about everything a well-written ticket actually holds. It carries the problem statement, the scope boundaries, and the exact acceptance criteria. It tracks the current status, links out to relevant artifacts, captures human comments, triggers retry or review signals, and maintains a direct connection to the underlying workspace. Because it holds all of this context in one place, the ticket becomes an incredibly stable unit of control. It is much more reliable and structured than trying to manage a project through an ad hoc prompt history in a chat window. The practical implication here is huge. As this shift continues, your issue tracker starts behaving less like a simple to-do list and more like the actual command layer of engineering work. The human operator's role evolves. Instead of spending all day typing away inside one live coding session, you will increasingly find yourself operating at a higher level. You'll be interacting directly with issues, managing status transitions, setting policy, clearing review queues, and handling exception states. You stop just writing the code and you start orchestrating the system. Now let's look at the clearest example we have in this course of the shift toward work-level control, OpenAI Symphony. Symphony matters because it fundamentally changes what we consider the basic unit of coordination. Instead of focusing your attention on a single chat session, a clever prompt, or a local turn inside your IDE, Symphony zooms out. It elevates our focus to the level of an actual issue, a dedicated workspace tied directly to that issue, an overarching workflow policy, and a persistent work lifecycle. To really understand why Symphony is important here, we need to stop thinking of it as just another coding agent. It is much better understood as an orchestration system. It coordinates the work flowing in from an issue tracker, spins up issue-specific workspaces, handles execution inside a secure harness, takes care of retries and state transitions, and provides observability across multiple runs. All of this makes it a powerful example of what we call work system orchestration. This brings us to the key conceptual shift. With Symphony, a live coding session is no longer the entire job. It becomes just one part of a much larger process. For you, the human, your center of control moves upward. Your new workflow is to define the work up front in the issue system. Let the orchestrated execution layer handle the bounded implementation tasks, and then return only for review, approval, or targeted intervention when needed. It is a completely different operating model. We are moving far beyond the days of simply sitting in the IDE and code typing with an AI assistant. Let's clear up a very common misconception. When we talk about moving control upward and automating more of our processes, it is easy to assume that the human is somehow being removed from engineering entirely. But that is simply not the right way to think about it. The human remains absolutely crucial to the process. What changes isn't our presence, but rather where we provide the most value. In this new paradigm, we place far less emphasis on manual, granular tasks. You won't need to type out every single line of code or micromanage every twist and turn of the implementation process. You also won't have to manually hold all that short-term transient context in your head or sit around babysitting a single drawn-out session. Instead, your focus and energy shift toward higher-level thinking. You will put much more emphasis on defining solid units of work and writing crystal-clear acceptance criteria. Your daily role evolves into spotting architectural mistakes early, thoughtfully reviewing outputs, and stepping in to handle exceptions. You become the key decision-maker on what deserves escalation or a complete redesign, and ultimately, you are the one shaping the workflow itself. This is exactly why we describe this shift as a reallocation of control rather than the elimination of it. You, the operator, are still entirely governing the system. You are just doing so from a much more powerful leverage-rich layer. Let's talk about why verification becomes absolutely central when we move up to the work level. The entire concept of work-level control depends on one extremely important factor. Verification must be strong enough that you, the human operator, do not need to micromanage every single implementation step. Think about it. If the system cannot reliably verify its own work, you are instantly forced right back into constant low-level supervision, which defeats the purpose of the automation. So how do we make work-level control viable? It becomes a reality only when the system can leverage a robust set of checks. We are talking about running tests, type checking, and linting. It means utilizing review steps, inspecting code diffs, and passing through approval gates. It also relies on continuous integration signals and structured error feedback. By using these mechanisms, the system can perform bounded work independently. It surfaces meaningful, actionable results to you rather than needing you to hover over its shoulder and watch every move it makes. The practical outcome of having this strong verification is transformative. When the system can check its own steps, your role elevates. Instead of supervising every intermediate keystroke, you get to review the work at a much higher, more strategic level. You evaluate overall correctness and how well the work actually fits the original ticket. You look at architectural alignment, assess any residual risk, and determine if the work is truly ready to be merged. You get to focus on the big picture. And that is exactly why verification keeps showing up as a first-class concern throughout this entire course. It is the foundation that makes higher-level control possible. Now let's explore why this fundamentally changes the user experience of engineering. When the main control surface shifts from an active local coding session to the work item itself, the ideal interface naturally has to evolve. Traditionally, the assumption has been that an engineer's center of gravity remains firmly inside local environments. You spend your day in the integrated development environment, the terminal, or perhaps a live coding chat. Everything revolves around that active manual session, but we are seeing an entirely new assumption emerge. The center of gravity is moving outward. Instead of the local environment, the primary interface might actually live in the issue tracker, the review queue, a broader workflow system, or a conversational control layer that surrounds the work. This is one of the main reasons why tools like Symphony are viewed as part of a much larger transformation in the engineering user experience. The whole system is moving toward higher level orchestration. Ultimately, this means human engineers will spend more of their valuable time guiding and managing the actual work, and far less time managing the repetitive nuts and bolts of local session mechanics. This lesson connects directly to a larger thesis we will be developing throughout the rest of the course. We are seeing a fundamental shift in how software is built. Agentic engineering is increasingly moving beyond the integrated development environment. Now, to be clear, the IDE is not disappearing. It is simply no longer the only or even the primary control surface for development. Instead, a new kind of technology stack is emerging to support AI agents. Let's break down what this stack looks like. At the base level, we have harnesses. These handle the actual local execution of code. Next, we have orchestration systems. These are responsible for managing the overall workflow, ensuring continuity, and handling automatic retries when a process fails. Then, we have issue systems. Think of these as the dispatch center, where the actual work to be done is clearly defined and tracked. And finally, sitting at the top of this stack are humans. In this new model, the human role shifts away from writing every line of code and moves toward governing tasks, setting policy, reviewing agent outputs, and stepping in when a problem needs to be escalated. When you put these pieces together, you get a much more scalable structure. It is exactly the kind of architecture required to support long-horizon, autonomous engineering work, where agents can be trusted to tackle complex, multi-step problems over extended periods of time. To really boil down the difference between these two modes, let's look at a simple comparison of what you, the human, are actually managing. When operating with session-level control, you are deep in the details. You are mostly responsible for managing the ongoing chat, crafting the specific prompts, keeping track of the local session state, and figuring out the step-by-step implementation sequence. You are directly steering the immediate, real-time interaction. Now contrast that with work-level control. Here your perspective zooms out. Instead of managing a single conversation, you are managing the broader task. Your responsibilities shift to overseeing the overall workflow state, handling the review and approval process, stepping in to deal with any exceptions or escalations, and prioritizing work across multiple different items at once. Ultimately, this isn't just a slight change in how you use a tool. It represents a fundamental difference in your operating posture, shifting your role from a hands-on, turn-by-turn operator to a higher-level manager and reviewer. Let's bring all of this together with our core takeaway. The ultimate goal here is to shift human control up to the work level. But what does that actually mean? It means we need to stop micromanaging our AI. We are moving away from prompt-by-prompt steering, where you have to hold the system's hand through every single implementation step. Instead, we are elevating the human's role to focus on higher-level tasks, defining tickets, managing workflows, conducting reviews, and setting policy. Now, you cannot just make this leap automatically. This shift is only possible when your orchestration stack is truly mature. To confidently step back, your infrastructure needs to support a few critical things. It needs bounded execution, so agents stay strictly on task. It also requires persistent workspaces, reliable validation, automated retries, and the ability to coordinate complex tasks right at the issue level. This is exactly why systems like Symphony matter so much in this course. Symphony is not just another tool. It provides a concrete example of the broader future of agentic engineering. It shows us a world where humans increasingly manage the overarching work, while orchestrated agents handle the bounded execution inside of that work. Ultimately, what we are looking at is not just a new set of tools. It is an entirely new control model for software engineering. Welcome! Today, we're diving into the fascinating world of work system orchestration to explore workspaces, policies, and ticket-based state. In this lesson, we'll look at how AI is evolving from simple chat sessions into structured, long-horizon work runs. We'll explore how the work ticket itself becomes your main control surface, operating hand-in-hand with isolated workspaces and governing workflow policies. Together, we'll walk through the complete lifecycle of a work run, uncover how the state of your work is distributed among these different parts, and understand why this architecture is an absolute game-changer for complex tasks. By the end, you'll have a clear key takeaway on exactly where the state of work lives, how it is governed, and why this matters so much for the broader future of agentic engineering. Get ready to completely shift your perspective on how AI manages work across time. Let's jump in. When we think about using AI coding agents today, our minds usually go straight to a live interactive chat session. You explain a task, the agent pokes around your code repository, and you gently nudge it along step by step. In this traditional setup, that single chat session carries almost all of the active memory and state. This back and forth is great for short, quick tasks. But for long horizon engineering work, it quickly becomes fragile. The context gets noisy, trying to restart or retry a step feels awkward, and the original work request often loses its connection to the actual code being written. Symphony introduces a completely different model. Instead of treating a fleeting chat session as the center of control, Symphony shifts the focus entirely to the work item itself. The work item becomes the main unit of coordination. The session doesn't disappear, but it simply becomes one bounded execution mechanism operating inside a much larger orchestration system. A really useful way to think about this new approach is to view it as an implementation run or a work run. It is no longer just an open-ended chat. It is a fully managed attempt to advance one concrete piece of work running inside a controlled environment and guided by explicit policies. Let's look at a major concept in Symphony-style orchestration: the idea that a work item becomes your control surface. In traditional setups, an issue tracker is just a passive planning tool, a place where you jot down what needs to be done. But in this model, the issue tracker becomes an active coordination surface. The system organizes work around a central unit. This could be a ticket, an issue, or a task in your workflow system. That item carries all the human-facing descriptions of the work. It holds the problem statement, the scope, the constraints, and the acceptance criteria. It also captures the ongoing conversation, like comments and review signals. Why is this such a big deal? Because it fundamentally changes the role of the ticket. It is no longer merely a note saying what someone should do later. It becomes the actual entry point for autonomous execution. You, as the human operator, steer the system primarily by shaping this work item. You guide the process by clarifying your intent, tightening the scope, setting expectations, reviewing outcomes, and handling any exceptions directly within the issue. The orchestration system then takes over, using that work item as its main coordination object. Now let's clarify one useful point. The issue tracker is best understood as the primary coordination surface, not necessarily the sole technical storage space for every piece of system state. Yes, some very important state lives directly in the ticket or issue, but other state lives elsewhere, like in the workspace, in the outputs of a run, or within your repository policies. The vital shift to remember is this: the ticket transforms into the main meeting place where humans and the orchestration system interact to get the work done. Now that we've organized our work into distinct issues or tickets, a critical question naturally follows: where does the actual implementation get done? This is where the concept of a workspace becomes absolutely essential. Think of a workspace as an isolated working environment dedicated entirely to a specific unit of work. In Symphony-style orchestration, every single work item gets its very own workspace. This ensures that implementation never happens in a shared, ambiguous environment where things can easily get mixed up. So, what exactly does this workspace give us? Primarily, it provides isolation, continuity, inspectable progress, and a highly durable place to store the operational state of a task. If you were to look inside one of these environments, you would typically find a full checkout of the code repository, the specific working changes for that task, generated artifacts, logs, test results, and any partial implementation states. But why go to the trouble of creating an issue-specific workspace? Well, it solves several major problems that arise when dealing with complex, long-horizon tasks. Let's look at 4 key benefits. First is isolation. Because each task has its own space, one piece of work won't accidentally interfere with another. This makes running multiple tasks at the same time highly manageable and safe. Second is continuity. If a process needs to pause, retry, or hand off the work to another agent or system, the next step can simply resume right where it left off in a real, persistent environment. There is no need to reconstruct the entire state from scratch, or rely purely on short-term memory. Third is inspectability. Instead of just taking an AI agent's word for what it accomplished, humans and other systems can actually look inside the workspace and verify exactly what happened. And fourth is safer bounded execution. By constraining the work to a clearly defined environment, we gain much better control. It becomes much easier to contain the work, reason about potential side effects, and keep our overall systems secure. Ultimately, this dedicated workspace model is one of the biggest architectural differences between advanced, higher-level orchestration and a simple back-and-forth coding chat. We have established that a ticket tells the system exactly what needs to be done, and a workspace provides the environment, or the where, for that work to happen. But a crucial third question remains: how is the work supposed to be carried out? Answering that question is the role of the workflow policy. In Symphony, there is a key idea that this policy should not be separated from your codebase. Instead, it lives directly in the repository as a versioned artifact. You will often see this saved as a simple text file named workflow.md. This is a very deliberate and strong design decision. Instead of keeping workflow rules hidden away in a remote dashboard or relying on undocumented habits passed around by your team, the system stores these rules right alongside the code. Because of this, your team can version, review, and update the policy exactly the same way it handles other important engineering artifacts. So, what exactly can this policy express? A workflow policy can define a wide range of parameters. It dictates how an automated run should behave and what constraints apply to it. It can specify what commands or checks are strictly required, what kind of evidence actually counts as task completion, and what the expectations are for code review. It can even define what the system prompt or runtime instructions should include. In the Symphony framework we are using in this course, that workflow.md file is not just a passive sticky note. It is an active part of the control plane governing the work. A practical way to think about this policy is as a contract. It serves as a binding agreement between your engineering team's workflow expectations on one side and the orchestrated agent run executing the task on the other. This elevates the workflow policy from a mere guideline into a first-class orchestration artifact. One of the best ways to understand this architecture is to realize that the state of your work doesn't just live in one place. Instead of imagining that everything is stuffed into a single chat thread or a hidden database, it helps to see that the state is actually distributed across three distinct layers. First, let's look at the ticket, or the issue. Think of this as the human side of the task. It carries the plain English statement of the work, the current workflow status, project constraints, and review comments. Essentially, the ticket holds the social and managerial identity of the task. Second is the workspace. This layer carries the operational state of the implementation. It is where the actual hands-on work happens, containing your files, code diffs, test outcomes, logs, and local progress. The workspace provides the concrete environment that allows you to pause and smoothly resume the very next step of your work. Third, we have the workflow policy. This layer acts as the rulebook. It carries the behavioral rules of execution, tracking all the required checks and expectations. You can think of the policy as a versioned contract that explicitly states exactly how a specific repository expects work to be completed. Adopting this mental model makes the whole architecture much clearer. The system becomes highly legible precisely because the state isn't jumbled together, but is instead carefully partitioned according to its actual function. Now let's bring all these pieces together and walk through the actual lifecycle of a work run in a Symphony-style implementation. Think of it as a journey. It all kicks off when a specific work item in your issue tracking system is flagged as ready for execution. Once that happens, the orchestration system steps in and automatically pairs that task with its own dedicated workspace. With the workspace all set up, the agent run officially begins. But the agent isn't just acting on its own, its entire process is strictly governed by the workflow policies defined by that specific repository. As the agent works, it keeps the system updated. Any progress, final results, completion signals, or even failures surface right back through the original work item and its related artifacts. This means you never have to guess what's going on behind the scenes. Finally, the human steps back into the loop. This is where you get to review the output, approve the work, give the agent new directions, or step in and escalate things if needed. Looking at this process from start to finish perfectly highlights why this architecture is fundamentally different from a standard AI chat session. A normal chat is just an isolated back-and-forth conversation, but here the AI session is just one component working inside a much larger, fully integrated work lifecycle. Let's explore why this specific structure is so valuable when we move into long-horizon autonomous engineering. If you recall from earlier in the course, we introduced three core challenges: scope, context, and execution. This framework directly strengthens our approach to all three. Starting with scope. In this model, the ticket acts as a perfectly bounded unit of work. It gives the system clear parameters, ensuring it remains focused on a specific task without drifting. Next is context. In a standard setup, context often disappears when you end a chat, but here, the workspace and the policy provide durable context. The vital information the system needs persists reliably, existing entirely outside of any single live session. Finally, we have execution. By utilizing the policy and the workspace together, we create an execution environment that is much more controlled and verifiable. The system operates within a structured space where its actions can be safely monitored and validated. This fundamental shift is exactly why work system orchestration feels qualitatively different from standard prompt-centered coding assistance. You aren't just sending prompts back and forth. You are providing the system with much stronger surfaces for continuity, governance, and review, making it truly capable of sustained long-term engineering work. Let's zoom out for a moment and look at why all of this matters for the broader future of agentic engineering. The concepts we are covering right now point toward a major shift in user experience, which is a theme we will explore much more deeply later in the course. Think about what happens when engineering work is organized through an automated system of tickets, isolated workspaces, and versioned workflow policies. When you build systems this way, the primary way humans interact with and control the work fundamentally changes. The human control surface moves upward. Instead of micromanaging every single line of code or every action inside a traditional development environment, the human operator steps into a higher level role. You find yourself managing the actual work items and overseeing the overall state of the workflow. Your focus shifts away from the minutiae and toward handling reviews, granting approvals, and stepping in only to resolve exceptions or escalations. This upward shift in responsibility is exactly why the Symphony framework is such a vital reference point for us. It gives us a clear, practical look at what agentic engineering truly looks like when the underlying architecture is centered on full-scale work orchestration rather than just simple interactive prompting. Symphony-style orchestration might seem complex at first, but it becomes much easier to grasp when you break it down into three main pillars. First is ticket-based state. This gives the system a durable surface for coordinating tasks, ensuring that nothing gets lost in the shuffle. Second, we have isolated workspaces. These provide each specific work item with its own concrete environment, creating a dedicated space where the actual implementation can persist safely. And third is the workflow policy. Think of this as a versioned local contract right inside your repository that clearly defines exactly how the work should be carried out. When you bring these three pillars together, they replace a very common yet highly fragile approach. They move us away from the idea that a single, long chat session should carry all the heavy lifting for planning, memory, execution, and control. And that is really the deeper lesson behind this entire architecture. Autonomous engineering work becomes significantly more reliable when the state of that work is distributed across the right durable surfaces rather than being trapped inside a fleeting, transient conversation. Welcome! Today we're diving into the fascinating world of architectural alignment and harness integration in agentic engineering. In this lesson, we will explore exactly how higher-level orchestration connects with the execution harnesses that do the heavy lifting. Together, we'll map out Symphony and the harness layer, unpack key integration surfaces like the codex app server, SDK, and MCP, and clarify exactly where ACP fits into the broader ecosystem. From there, we'll explore OpenClaw as a chat-native frontend and discover why decoupling your interfaces, harnesses, and work systems is absolutely critical for the future of developer experience. By the end of this overview, you will have a crystal clear takeaway on how to structure scalable agent-driven workflows. Let's get started. Let's explore the architecture of our system by looking at two critical components, Symphony and the harness layer. Understanding the relationship between these two makes the entire system much easier to understand and work with. Think of Symphony as the big picture manager. It operates at the work orchestration layer. Its primary job is to oversee the entire lifecycle of a piece of work. This means Symphony takes care of the high-level logistics. It handles tickets, enforces workflow rules, and sets up issue-specific workspaces. It also coordinates the complex processes, like managing concurrent runs, automatically triggering retries when things fail, facilitating handoffs for peer review, and providing system-wide observability so we always know what is happening. Now, while Symphony is orchestrating the process from above, the harness layer is on the ground performing the actual local execution. If Symphony is the manager, the harness is the hands-on worker. Operating entirely inside a designated workspace, the harness handles the practical steps of getting the job done. It is responsible for direct tool use, editing files, and running commands in the terminal. It also handles local reasoning, keeps track of the immediate session state, and runs bounded validation steps to ensure the task is being completed correctly. By keeping a strict separation between these two layers, our architecture remains incredibly clean and scalable. To sum it up, the harness actually executes the tasks locally inside a workspace, while Symphony, the orchestrator, manages how the work reaches that harness, tracks its overall progress, and smoothly advances it through the broader workflow. Now, let's explore how a work orchestrator interacts with a harness and what it means to orchestrate work above that harness layer. In a very practical sense, an orchestrator depends on a harness because it requires an underlying execution engine to actually get things done. You can think of this execution engine as something like Codex, Claude Code, OpenCode, or any comparable system. But what really matters here, architecturally speaking, is the clear division of responsibility between the two. Let's break down who does what. You can think of the harness as the hands-on worker. Its primary job is local execution. It handles all the direct file and tool operations and manages that immediate turn-by-turn work. Ultimately, the harness is focused on making bounded, steady progress on a task right inside the workspace. The orchestrator, on the other hand, acts as the high-level manager. It handles work intake, pulling in new tasks from your tickets or issue tracking systems. Before the harness can even start working, the orchestrator is the one provisioning the workspace and loading the correct workflow policies. Once work is underway, the orchestrator handles run dispatching and concurrency control to make sure the system operates smoothly. It's also there to manage retries and escalations if something goes wrong, while providing overall reporting and observability so you know exactly what the system is doing. This division of labor is incredibly important. By separating the hands-on execution from the high-level management, the system is able to coordinate complex work at a much broader scale, reaching far beyond the limitations of just a single session. Let's talk about why the Codex app server is so important. Its real value lies in how it exposes Codex. Instead of acting as a simple one-shot model interface where you send a single prompt and get a single reply, the Codex app server acts as a deep embeddable runtime. Why do we need that? Well, a deep runtime is incredibly useful when a larger system demands more than just a quick, isolated response. Think about complex applications. They often require persistent conversational threads or the ability to track multiple turns and items over time. They might need to process real-time streaming events, handle user approvals, or maintain a stateful, ongoing interaction that connects to another product or service. Essentially, these systems need much richer lifecycle control. Because it can handle all of these complex requirements, the Codex app server is an exceptionally strong fit for modern software architectures, particularly those where the AI harness sits right underneath a broader orchestration or product layer. In practice, this means a top-level work orchestrator can confidently rely on that deep underlying AI runtime to handle complex interactions while it continues to manage the overarching lifecycle of the work from above. When working with modern harnesses, they usually connect to the outside world through a few different integration surfaces. Three of the most common are the MCP server, the SDK, and the app server. Each serves a distinct purpose, and understanding the difference helps clarify exactly how a higher-level system interacts with the harness beneath it. Let's start with the MCP server. This surface is incredibly useful when another AI agent or orchestrator wants to consume the harness simply as a tool. Think of it as a way to expose specific capabilities for another system to quickly pick up and use. Next is the SDK. You will want to use this surface when your backend code, automated scripts, or host applications need direct programmatic control. It gives developers the raw building blocks required to command the harness directly from within their own code base. Finally, we have the app server. This surface is designed for richer products and complex orchestration systems that need deep, ongoing integration. If your system has to manage continuous user sessions, process event streams, handle human approvals, or maintain long-term continuity, the app server is what makes that possible. Making these distinctions is important because it defines the relationship between your tools. For example, a dedicated work orchestrator needs much more than a simple one-off call to a model. To be truly effective, an orchestrator relies on a robust integration surface that can support and sustain real, complex execution flows from start to finish. Now let's explore where ACP fits into the broader picture. Both ACP and the Codex app server are essential tools in modern agentic engineering, but it is important to understand that they solve completely different problems. They actually belong to different layers of the technology stack. Let's look at the Codex app server first. You can think of this as an embeddable runtime surface specifically for Codex. Its primary job is to take a specific harness and embed it deeply inside another system. It is all about tight, specific integration. ACP, on the other hand, is a client-agent protocol. Instead of focusing on embedding a specific runtime, ACP provides a standardized way for clients and harnesses to communicate with each other. It is focused entirely on interoperability, ensuring that different clients can seamlessly talk to various agent backends using a shared language. This distinction matters because understanding it helps us build better systems. One layer handles the deep, specific embedding of a runtime, while the other handles the broad, standardized communication across different systems. Even though they serve different purposes, both the Codex app server and ACP are incredibly valuable, and both contribute to creating a much more flexible and modular overall architecture. Let's zoom out for a moment and look at why ACP matters for the broader ecosystem. At its core, ACP points toward a future where an AI agent is no longer tied to a single specific interface. What does that mean in practice? It means the client interacting with the agent can be virtually anything. It could be an integrated development environment, a chat system, a web application, a network gateway, or really any other external control surface. This kind of separation is incredibly powerful. It makes it significantly easier to build dynamic ecosystems where the exact same agentic backend can be accessed seamlessly from multiple environments, depending on what the user needs in that moment. Ultimately, this completely changes how we think about the word interface in the world of agentic engineering. The most important question is no longer about which editor window or dashboard the human happens to be using. Instead, the focus shifts entirely to the underlying architecture, asking which protocol and orchestration layer are actually governing the work. Let's look at a practical example of this shift by exploring OpenClaw. OpenClaw is a fascinating tool because it treats chat as a serious operational front end for agent-driven work rather than just a simple communication channel. Think of OpenClaw as a gateway. It acts as a bridge, connecting your everyday messaging channels directly to your coding agents. It makes this connection by exposing the agent interactions through a standardized protocol layer, such as ACP. When you put these pieces together, you get a powerful architectural pattern made up of 4 distinct layers working in harmony. At the base, you have the harness, which provides the local execution engine where the actual work happens. Next is the protocol layer, which takes that harness and exposes it so that different external clients can securely connect to it. Then we have the gateway, or the client itself, which provides the human-facing interface. This is the part you actually interact with. And finally, sitting above all of these components is the work orchestrator. This top layer is responsible for managing the tickets, the workspaces, and the overall state of your workflows. The real magic of this architecture is that it opens the door to a chat-first development experience. Instead of being tied down to a single traditional integrated development environment, an operator can now manage, direct, and supervise complex engineering work entirely from a conversational interface. It represents a flexible, highly collaborative new way to build software. Let's move on to the crucial concept of decoupling the interface, harness, and work system. One of the most important architectural trends in agentic engineering today is the separation of concerns across different layers. Let's break this down into 4 key layers. First is the interface layer. This is simply how a user or external system interacts with the agent. It might be an integrated development environment, a chat client, a web app, or a gateway like OpenClaw. Next, we have the harness layer. This is where local execution actually happens. Think of coding agent environments like Codex, Claude Code, or OpenCode. The harness provides the immediate contained execution space for the agent to do its job. Below that sits the programmatic integration layer. This acts as the connective tissue of our architecture. It includes software development kits, application servers, and standard communication protocols like MCP and ACP, which allow different components to communicate seamlessly. Finally, we have the work orchestration layer. You can think of this as the overall manager. It handles the heavy lifting of coordinating complex operations. This system manages support tickets, sets up workspaces, enforces workflow policies, and automatically handles retries. It also provides system observability and juggles multiple pieces of work happening at the exact same time. By adopting this layered view, complex systems become much easier to understand and reason about. Each layer has a distinct, focused purpose. Most importantly, this decoupling means each specific layer can be updated and evolve on its own without running the risk of collapsing your entire architecture into a single rigid tool. So, why does all of this matter for the future of development user experience? Ultimately, these architectural layers are paving the way for a massive shift in how we build software. The center of gravity in development is moving upward. We are stepping away from the traditional model of micromanaging a single coding session inside a single integrated development environment. Instead, we are moving toward managing work at a much higher level, focusing on overall tasks, automated workflows, code reviews, and handling exceptions. But to make this leap, the underlying technology stack has to support a few critical capabilities. It requires strong local harness execution, rich programmatic integration, protocol-based interoperability, and higher-level work orchestration. Let's look at how the pieces we've discussed fit into this new world. Symphony steps in to handle that high-level work orchestration. The Codex app server acts as a rich, embeddable harness runtime. ACP provides vital protocol-level decoupling, cleanly separating user clients from the agent backends. And OpenClaw elevates chat, turning it into a serious operational interface for agentic development. When you bring all of these layers together, the result is truly transformative. They support a model of software engineering work that is significantly more flexible and powerful than anything we have seen before. Let's bring this all together with our key takeaway. When we talk about architectural alignment in agentic engineering, success really comes down to one core principle: keeping your layers distinct and clear. Think of it as a stack with 4 distinct areas of focus. At the foundation, you have the harness. This is the engine room where the actual local engineering work gets executed. Right above that is the integration surface. This layer acts as the bridge, securely exposing the harness to your host systems and clients so they can communicate effectively. Next up, we have the work orchestrator. Operating above the harness, this layer acts as the manager. It handles the complex logistics, like tracking tickets, organizing workspaces, enforcing workflow policies, and managing the life cycles of various runs, because these underlying layers handle the heavy lifting, the role of the human shifts. Instead of having to babysit raw, live sessions, we can now increasingly interact at a higher, more meaningful level, focusing on the actual work being done. Ultimately, adopting this layered architecture is one of the clearest signs that the field of agentic engineering is maturing. By separating these concerns, we unlock the ability to build richer products and much more flexible interfaces. It provides stronger overall orchestration, and most importantly, it creates a developer experience that is focused entirely on the work being accomplished, rather than just trying to control a live session.